Okay, um, good afternoon. I wanted to first give us a sense of a classical experiment. So I wanted to do a brief lecture going over this particular concept so we have a better understanding of what a classical experiment is trying to do. Now, unlike other experiments, classical experiments, as the PowerPoint reports or provides information on, is classical experiments give us a opportunity to isolate a treatment effect and evaluate the treatment's effect on a dependent variable specifically, rather than along with other particular variables. So what a classical experiment is really trying to do is to isolate the effect the treatment has on a dependent variable, where we can positively say that any effect or any change in a dependent variable is in fact the treatment operating and not other outside variables. So within a classical experiment, we of course have independent and dependent variables. Our independent variable by terminology is just the treatment. For example, if we are doing medical research and individuals are placed into two groups, an experimental group and a control group, and we're looking for a particular drug to better treat the patient, any effect in the patient is solely based on the treatment and not some outside variable, whether a patient leads a healthy lifestyle, exercises, doesn't smoke, doesn't drink, so forth and so on. So we want to essentially cancel out those particular factors and isolate the treatment effect. So when we say, okay, well, this particular treatment, for example, lowers blood pressure. Well, we want to be in a situation where we can say, yes, it's just this particular treatment that is affecting the blood pressure and not other outside factors like the individual's exercise routine or diet or something like that. So that is the purpose of a classical experiment. Now, in criminology and criminal justice, we really don't get many classical experiments because the central focus or the central component of a classical experiment is in fact random assignment. And I have a bit of a diagram to illustrate this point. So what we have here is an experimental group and a control group. And this is our treatment. And of course our dependent variable. Let's make this dependent variable recidivism. And we want our treatment group to be a, let's just say a drug court program. So we want to isolate the effect on how individuals that participate in a drug court program, how it reduces recidivism. However, there are a lot of characteristics that might predict recidivism outside of just participating in a drug court program. What we are attempting to do then is to cancel out the influential factors of those particular, what you see here in the middle, these covariates, so we can isolate the treatment effect and say, hey, well, it's just this program that is reducing the recidivism, or doing nothing to the recidivism. So I have here, so other independent variables are typical independent variables such as demographic information, such as age, gender, race, employment status, educational attainment, those are positioned as what we call covariates. Now, they're still independent variables, but what we're trying to do is cancel those out. So let's put down some covariates. So we put down age, race, gender, employment, education, prior criminal history, and so forth and so on. So we have these particular covariates. Now, we have, say, a group of 1,000 offenders, drug-involved offenders, if we will, and we want to see if, of course, participating in a drug court program is going to affect recidivism. So we randomly assign these 1,000 offenders into either an experimental or control group. And so 500 are going to go in here, and then 500 will go into here randomly. By having random assignment, what we're able to say then is that these two groups are equal on all covariates. Not only are they equal on the covariates we know, which is age, race, gender, employment, education, and prior criminal history, but they're also equal on things we don't know. So other covariates that we listed here might be their drug of choice, their charge of record, all the way down to, do they have children? Are they married? So forth and so on. So that is the point of a random assignment or a classical experiment. So if we come here, and let's see if this works. So what we attempt to do through random assignment is it just cancels everything out. Because the two groups are equal, none of these essentially matter, or they're not going to be influential, or they would be influential, but not within our experiment because the two groups are equal. So it doesn't necessarily matter what these covariates are, because the fact that it's equal between these two groups cancels them out. Subsequently, by canceling all of those things out, we can then say any effect in recidivism is solely due to participating in the drug court program, which is in fact the experimental group. Those are the ones that are getting the quote-unquote treatment. Other terminology for it is the stimulus, the manipulation, of course, the independent variable. So any of those particular these particular covariates aren't a matter, or do not play any influence on recidivism, because the difference in recidivism between these two groups is now solely based on whether or not they participate in the drug court program. But a key issue to remember is that when you have the experimental design, and what makes it so important, and I want to reiterate this point, is that not only are these groups equal on the things we know, which is age, race, gender, employment, education, prior criminal history, but on everything we don't know. By randomly assigning this, it cancels out the observables and the unobservables. Now, what are the things that we know? The things that we know basically are those in real life come in a data set. So any data set that we use, and of course that paper that you read earlier in the particular semester, has independent variables or offender characteristics, but it doesn't have everything about an offender, all the way down to, whether they went to a public high school or a private high school, or whether or not they lived in a single family home or single parent home, or a two-person or two-parent home, and so forth and so on. So, of course, no data set's going to have every single variable possible. I mean, if you think of yourself, you're made up of millions of characteristics. So the thing about the experimental design, then, it captures all of that, even though we don't know it, by random assignment, making these two groups equal. By making them equal, it cancels out every covariate, the observables we know, which is these 6, and every observable or unobservable, things we don't know, which is thousands. And by making them equal, cancels them out. What we're left with is just the treatment and its effect on the dependent variable. So, well, in the next particular video, we are of course going to cover the assignment. And what we're looking to do is, in a sense, replicate this idea of a pretest post-test, where the pretest is essentially our control, the X is our treatment, and the post-test is our experiment or our treated group. Because if you're looking at this as far as time, the control group hasn't passed through the treatment or hasn't been manipulated yet. So that's why these are the control group. You go through time, essentially being manipulated by the treatment, and subsequently when you take the post-test, you have been treated, and essentially the same population is now the experimental group. So if you're looking at it from a standpoint of taking a research methods class, and the pretest is a exam on the first day of class, and then the same exam is given on the last day of class, the treatment being the actual semester or taking the particular course, of course time is 16 weeks, then the class of 30 on day 1 is the control group. 16 weeks pass taking the particular class, which is X, and then those same 30 individuals are essentially the treatment group taking the post-test. What, of course, we would expect is that individuals would score higher on the test after taking the course rather than before. So what we then would expect is then the treatment effect. You know, by taking the class, individuals know more about research methods. So I hope, you know, before we get into the actual assignment, that that point is made and made more clearly, so you understand what's kind of happening within some of those questions within the assignment on experimental design. So the next video will be on the assignment.